Hey everyone, welcome to this tutorial. In this project, we're going to use Python to create an NFT art collection from scratch. We're going to start with an empty project and go from that to something looking like this in the next 45 minutes. And I'll be showing you how to do this step by step, with each one adding something new to our image generating process. Before we start, I just want to give you a little bit of a background context on what we're actually building here. I recently created an NFT art collection where each image is generated by Python and then each given a unique title by OpenAI GPT-3. I did this as a way to learn about NFTs, especially from a technical standpoint, especially given how much buzz it is generating on the internet right now, with some pieces of art selling for hundreds of thousands of dollars. And as part of this effort, I ended up creating a Python script to generate artwork, an OpenAI prompt to give each one a unique title, a React front end as a gallery, and an ERC 720 contract to deploy the collection onto the Ethereum blockchain. Although I didn't end up using the actual contract since there is a massive cost to deploy it, so I just uploaded these images to OpenSea instead, where the cost of publishing to that is free. In this video, I'll be focusing on the Python process used to generate each of these images, which I think is the most important, or at least the most interesting part of this project. And as always, I've included the GitHub links to both the original project and the simplified tutorial version of this project in the description below. Generative artwork is already quite a big deal in the NFT scene. One of the most famous collections in this category is called Art Blocks, with some pieces from that collection selling for upwards of millions of dollars. The generative algorithm on Art Blocks is a lot more complex than what we're building today. And what's more, the Art Blocks images are saved onto the Ethereum blockchain itself, whereas the ones we're doing here today are only saved as conventional PNG images. So it's not quite the same thing, but we have to start somewhere. To follow along with this tutorial, all you need is some basic Python knowledge. I'll be using Python version 3.6 and VS Code as my editor. We'll also be needing to use the Pillow library, so you also need to know how to install packages using a Python package manager such as pip. By the end of this video, you'll know how to create and save images in Python, draw things onto the image, and manipulate the color channels. And hopefully that gives you a solid foundation on image generation and processing using Python, especially if you haven't done it before. So I think that's enough background context for now. Let's go ahead and get started. Okay, so we're just going to get started with a completely empty project. First thing to do is obviously create our file, generateart.py, and we're just going to make a function that runs the whole thing. Say hello world. I always like to start projects with a hello world. Okay, so now that we have this, let's just test it real quick, make sure it runs. All right, it works. Let's change this to something more appropriate. Generating art, run. Okay, still works. Also, we should probably do this properly. Add this snippet here, which this means that this will only run if this file is run directly as a script. So if we import this into another file, this will not execute with this condition. But that shouldn't change things for how we run it here. Okay, so now we've got the program, we've got the way to run it. Let's actually create an image and save it into the folder. First, we're going to need an external library, the only one we need for this whole project, which is Pillow, Python imaging library. We install it like this, pip install Pillow. So to create an image, we need to first import the image module. And we can just create it like this. The arguments are mode, size, and color. Pretty sure mode is just the color mode, and RGB should just be the default one we use. So that's the red, green, blue channel. Size is a tuple, guessing width and height, and then color also a tuple, probably the RGB values. Yeah, let's just try that. So let's make it 128 by 128, and then the color can be, well, I think the RGBs usually come in two forms. They either max out at 1, so the values are between 0 and 1, and it's a floating decimal point, or each value is 1 byte, which means it has a max number of 256 values. So 255 would be the maximum in this case. This should give us a white image. So if we run it again though, nothing happens because we just generate this image in memory and we don't actually display or save it. So let's just go ahead and save it real quick. And that's just the file path we want to use. If we don't put anything like, at the top, then that just means that we save it to the directory that we run it from. So give that a shot. And now it appears. And if I click that, we should see our white square. I'm gonna just see if I can put this on the side actually, so we can watch it change as we are working on this. Okay, but before we go further, let's just clean this up a bit and get all of these values out so that it's a little bit easier to read. Let's go with image size pixels, B128, like this. And then image background color can be, okay. Okay, so let's run it again, make sure it's still the same, and it is. Okay, so that looks pretty good. We've got our image, we've got our values extracted here. I'll put that on a different line so we can actually see it. And I think these are keyword, these are keyword arguments as well. So might as well just declare them so that we can look at these list of arguments and it's immediately clear what each one is referring to. Okay, so we've created our base image. The next thing I want to do is add some details to this. So very easy way is just to draw some lines on top of it. To draw lines on the image though, we have to create something called a drawing interface with Pillow. So there's another class for that. And we do it like this. Well, actually, I'm just gonna draw some lines. Okay, this is basically just an object we can interact with to modify the image here. And if we look at the functions it has available, it's got line, text, point, polygon. We just want to use the line. And the arguments, it has XY fill, which is the same as color, I think, and the width of the line. So XY is the position. So I think if we try it out, we could just do something like this. Well, a line has 2 points. It's drawing from one point to another, so it needs 4 values because each point has an X and a Y coordinate. I don't think it matters if it's flattened into one tuple like this or whether it's separate, like explicitly into 2 points like this. I think this is probably better though. So let's say we wanted to draw a line from the top left corner, which is 0, 0. I'm assuming this is how Python's Pillow's coordinating system works. This would be 0, 0, so this would be whatever the value size of our image is, which is handily right here. So to draw a line from this corner to this corner, we'll just do this. I don't know if it actually has a default color or thickness value. Let's give that a shot and see if anything happens. You don't really see anything change here. We probably need a fill. So if the image is white, let's make the line black so that it stands out. Okay, so now it shows up. Great. In fact, let's put that into a variable as well, because we want to change that later. All right. Okay, we still have our single line drawn across. Okay, now one line is really interesting already, but I think we're probably going to need a little bit more. So let's go ahead and run a loop here to make it draw a few more lines. I think we only need to create the drawing interface once, so we don't have to put this into the loop. We'll start the loop from here. For I in range, say 10, we're just going to keep drawing lines. But if we don't change it, then we're just going to draw the same line over and over, and I don't think anything will happen. Yeah, it's just on top of each other here. So for each point, I'm going to pick a random point in this size, this image size. I could do it like this, I guess. Random point. Well, we're going to need a new library. Okay, we'll import the random library, and we'll go with random randint between two integers a and b, including both endpoints. That's fine. So this is how we get a random point between 0 and the max image size. But it is a point, so we'll need to do it twice. We actually need 2 points. So we'll do this twice. All right. Already not starting to like where this is going, but let's just get it done for now. Okay, so we've got 2 random points now, and then we're going to draw a line between those two, and we're going to do this 10 times. We don't even need this I, so I'm just going to do an underscore here. Usually that's a notation for saying that, oh, we need a variable placeholder, but we don't actually intend to use it. All right, I've got a bunch of random lines. Looks a little bit better, but still a bit too random. So the next thing is I probably want to give this a little bit more intention. I can do that by connecting each line. So instead of just drawing a bunch of different lines randomly, I can make each one join to the next line that is being drawn, so there's at least some kind of shape coming out of it. All right, so let's give that a go. To do that, I probably, instead of wanting to generate random points each time, I want to generate just a set of random points, and then I'm going to connect those points with lines, and then when I reach the last point, I might make it join back with the first point. So let's give that a go. We actually might need 2 loops here. Yeah, just go ahead and copy this. We'll create our points array. We don't need 2 random points, we just need 1 because we're putting in 1 at a time. And then I'll do points append random point. Okay, so now I'll have 10 random points in this array, and let's label this actually. Generate the points, and in this one we'll actually draw the points. Well, here we don't need to, actually we need an iterator now, because we need to loop through this point array. So I'm going to do this. I'm going to call these P1 and P2. So we're going to draw from P1 to P2. P1 is obviously going to be our point that we're using here. And P2 is going to be the next point in the list, except when we're at the end of the list, in which case it's the first point, because we want it to connect back. So we need to first check if we're at the end of the list. We can check if I equals to the length of points minus 1. If it is, then our P2 is the very first point. Otherwise, P2 is the next point. So now the points should be connected. Let's give that a go. Okay, looking good. Well, now we have some kind of shape. I kind of don't like how it's sort of really cramped at the edges here though. It doesn't look like good spacing to me. So I want a bit more negative space. We're going to add a bit of a padding and say that the valid boundary to draw is within a certain distance away from the edge. So we can do that by coming up with a padding number and then just setting this randomization to be in between those numbers. All right, let's go ahead and do that. Padding pixels, let's say 10%, guess. It's about 12. And we can now only random between 12 and the size minus 12. So that brings in the edge a little bit. Okay. See, that works. So now we should no longer have something that's just like really close to the edge. They should all be fairly centered. Okay. Actually, I might see what it looks like if I increase it a little bit more. Let's give that a go. Oh, it's good enough. Okay, cool. Make this a bit smaller so we can see more. All right. Okay, so we've got a shape. We've got it away from the edges. Let's make the shape a little bit more interesting. So an idea I have is to actually, if you remember drawing the line here, we also have this width parameter. So I actually want to see if I can change the thickness of the line as we're drawing it, just to make it look like the shape is more dynamic. If we start with thickness 1 here and use that, we should still see the same results. But now on each loop of this, I want the thickness to go up. So actually, let's initialize it up here, and then here, make it gain 1 thickness. I guess we should do it 0. If we're gonna add thickness here and we want to start it at 1, we should start this one at 0. All right. Okay. That's interesting. All right, so the shape looks a bit more dynamic now. There's kind of like, it gains weight as it's moving around the canvas. Okay, so now I've got the thickness of the line changing. I've got the canvas. It's starting to look pretty interesting to me. Next step is let's add a bit of color to this and see what that looks like. So if you recall, the color is here. And I can make each line have a different color. So what if I just do a random color thing here like this? Yeah, I'll make that into a function because I might use that a little bit more than just once. So this will return a random color. And if you remember, the color is between 0 and 255. We just need to do that 3 times, 1 for each channel. Okay, let's give that a go. So now each one should have a random color. Okay, that looks pretty funky. But if you have too many colors, I think it just looks a little bit clashing. So what I kind of want to do is have it start from one color and then change as it goes, slowly fade into another color. So I want a starting color and an ending color. And I want to be able to change between them as I'm going through this shape. So let's go ahead and do that. We'll do it up here actually, since this is where we're all setting the colors and everything. So we're going to say start color equals random color and end color equals random color. Okay. So now if I add the start color to here, well, it's all just going to be a solid color. And that's fine, but what I wanted to do is, as it's going through the shape, fade from my start color towards my end color. Okay, so I'm going to need a function to interpolate between these two color values. Let's just make that here. Interpolate. Then we're just going to do C1 and C2, and we're going to do a factor, which is going to be a float. Okay, so the factor is going to be between 0 and 1, and if it's 0, it's going to be completely color 1, and if it's 1, it's going to be completely the end color. Actually, let's just call it like this, make it a little bit more clear. Okay, and if it's 0.5, it's going to be halfway between start color and end color. So this way, if we can work out the factor, which is just linear from 0 to 1, we'll be able to get a nice gradient. But first we have to figure out how to do this between each colors. It's actually quite simple, I think. For each channel, actually, we need to first work out the reciprocal of factor. I always don't manage to spell this word, so I'm just going to write recip. So reciprocal and factor always add up to 1, and for each channel we can just do this. Start color times, hold on, if we want factor, if we want this to be full when this is 0, okay, so this is times the reciprocal, plus end color times factor. Okay, and we'll just repeat that for each of the channels. We have 3 channels, so 3 times red, green, and blue. All right, and now if I use interpolate down here, I should be able to get my color. So what's our factor going to be actually? We have this iterator here, which is going to go from 0 to the length of this -1. In fact, we already have the length of this -1 here. So I'm going to extract this here. If we divide this by the length, we should get a number between 0 and 1, which we can use as our factor. Okay, so I'm going to store that here since we're using it twice. I'll have to perform the same calculation twice. And this is just going to be I -1, there, color factor. Oh, also I forgot, we probably need to convert all of these back to integer, because when we do this multiplication, it's going to turn it into a float. I don't think our framework will be happy about that. So let's put these brackets back on. All right, let's run this. Okay, there we go. So now there's a little bit of a fade going on. Okay, that's pretty good already. Something I've noticed as well is that sometimes these images aren't exactly centered. Let's see if I can find an example. Like this one here. It's because we generate random points, there's no guarantee that it's going to be evenly distributed on the canvas. So we end up with something that can just like sort of be lying in a corner here. So what we're going to do next is try to center this image. Before we center it, let's first generate a bounding box around the image, because we want to see where, if we drew a box around it, what it actually looks like. Because sometimes like the shapes, it's kind of hard to tell where the edges actually are. So next process is to draw a bounding box. And to draw the bounding box, we'll have to find the minimum and maximum value of all of the points. And we'll use that to draw a box. Okay, so we have to do that after we generate the points. And we need the minimum and maximum of each value. So start with x. So to do this, we can use the min function. We just have to pass in an array of all the possible x values in here, which we can get by doing this. For p in points, it's not just p though, it is p0 because x is in the 0 index. And we'll also need max. And we need to do the same for y positions. Okay. So we've got our points. Now I actually want to draw the rectangle. I think I could just pass in all of these points. Not sure. Let's give it a go. I think they might have to alternate though. It's just my feeling. Fill, oh, we don't need a fill. We want an outline. Okay, let's make the outline red. All right, see if it works. Oh wow, okay, so we've got our bounding box. And you can already see that, yeah, it's not very centered. There's, this one is a little bit too high, so we want to move that down, and maybe also a little bit to the left. To do that, we have to work out what the difference is between its distances from the edge, x and y respectively, and then move it halfway in the direction that it's overcompensated in. So yeah, I think that's, so let's first work on getting these gaps away from the edge. If we have one that's really off center, okay, like this one here. Okay, so if I want this distance, I want this distance here, I also want this distance here. This is going to be, well, this is just going to be min x, because this is 0, so this is, yeah, this distance is literally min x. And this distance is the size of the image minus max x. And I want the difference between them. So I could do this minus this. Okay. Okay. What do I want to do with the delta x though? So in this case, this minus this is going to be a negative number because this one's bigger. But I want it to move to the right. So I need to negate it again. So basically I need to subtract delta x from all of my x coordinates to move it to the right. Because the delta x here is going to be negative, right? This is smaller than this. So a small number minus a bigger number, that's going to be negative, but I want to move it to the right, which is a positive number, so I'll have to subtract it from each of the x positions here. But I only want to subtract half because I don't want to move it all the way. I just want to move it halfway between these 2 points. Okay, so let's give that a try. For I point in enumerate points, delta x. We're going to leave y unchanged for now. We'll go back and deal with it later. Okay, so if this works, then the y position's just going to be the same. Let's give that a go. Okay, so I think this is working, but if you just look at the box, you can still see that it's off-center. That's because we draw the bounding box before we center the points. So let's make it so that we draw, well, actually no. Let's keep this one and let's draw another set of bounding boxes after we center it. And I'm gonna make this one, light gray. Just gonna turn all these values to really close to white. So where do you go? Okay, and then I'm gonna keep the new one red, so we can see how that looks. Yeah, okay, so you can see now that it used to be a little bit off-center and it's just shifted over slightly. And the y position is still obviously not fixed because we haven't implemented that for y yet. Okay, so I'm pretty happy with the x formulation. Let's do the y one as well. And delta y is gonna be, yeah, similar. Well, it's literally just the same thing, but with all the y positions. Okay. Let's give that a go. Yep, you can see now all our images are happily centered. Okay, cool. Well, we don't need this stuff anymore, so I'm just gonna remove it. Don't need this anymore. Okay. All right, now we're getting somewhere. I kind of don't like how the colors just overwrite each other. I kind of wanted to make it look like it's blended a little bit better. Almost like each line was drawn like a streak of light, so it kind of lights up everything that's underneath it. And the way we're going to do that is, instead of just overwriting the pixel values here with the color that we're drawing with, I want to overlay it onto the pixels behind it. So add it together with those values. The first thing that means is that we have to make the background black, because if we add anything to white, it's already at its brightest and it's just going to stay white. So if I want to make this look like a piece of lighting art, I need to first start off with a dark canvas. So let's go ahead and convert this to black. All right. It's a bit more interesting. Now I want to add each of these ones on, but I can't just, the drawing interface, I don't think it has an option for us to choose how to add these things on. So what I'm going to have to do is draw these lines on a separate black canvas, which I then add the whole two canvases together as I'm going. So let's see what that looks like. I'll actually have to create the new canvas every time for each line, because every time I add it, I'm going to throw that one away and I'm going to create a new one for the next line, so that it's not adding the same lines over and over. Otherwise those lines become very bright as time goes on. So let's give that a go. I'm going to do the same thing here. Let's create our own image. Everything is just the same. Background color is still black. We are also going to need an overlay drawing interface. Okay. So instead of drawing the lines onto my original image, I'm going to draw it onto the overlay image. Everything else can stay the same for now. If I run this, my art should disappear because I don't actually do anything to the original image itself. So I've got all of these overlay images in memory now, but I need to add that to the original image. The way to do that, there's another class from Pillow called image chops, which actually is kind of a cool name, but it just stands for channel operations. And that will let us add those two things together. So we're going to do this. Here, image chops, add, and there you go, image 1 and image 2. And if you run this again, still see nothing. That's because this one doesn't actually add it to, it doesn't add it to the original image. It does, but it doesn't modify the original image. It returns a new image. So we actually have to keep setting the reference of our original image to the result of this. Run it again. All right, now we got something. Okay, that's pretty cool. Okay. All right, so you've kind of noticed that every time I run this, I kind of want to test the change. I have to run it many times just to see different varieties of the generation. To save myself a bit of time, I want to actually make this generate 10 images at once. So let's go ahead and do that. Let's first make generate art accept a path parameter for where we're going to save the image. And then we're going to loop through it. So we're going to go here like this. Path string. And instead of saving it to this hard-coded spot, I'm going to now put in like that. So if I actually do this, test image.png, my program should still work exactly the same way. Just make sure it does. Okay, that's good. Now I can loop it. Let's say we want to do 10 at a time. We'll just change the name. Make this a format string, then add in our index. So now I should have 10 images when I run this. There we go. Yep, pretty interesting. Not sure why my arrow key doesn't work for this. Okay. So let's open this here on the side just so we can see it. The color generation is good, but in some cases, I think they can be quite plain as well. Like for example, this one here, I want brighter colors, whereas this one's a little bit desaturated, so closer to gray. And this is okay, but maybe I wanted to have more dramatic changes and not just be sort of like the same color. This one's just really desaturated. I mean, it looks kind of cool, but it's a little bit too pale. So what I want to do next is come up with a random color in a way that it's always bright. Now, each of these channel values, R, G, and B, we can randomize between 0 and 255, but I only want the hue of the color to change, which is like what shade of the color it is. I don't want the brightness or the saturation to change. So in order to do that, I need to use a different way to define the color. Instead of red, green, and blue, I'm going to use something called HSV, which stands for hue, saturation, and value. So if I keep saturation and value at max, which is 100%, they're always going to be bright and vivid. And if I just change the hue, then I can have different colors that also are bright and vivid, as opposed to darker colors or less saturated colors like this. But the problem is if we do HSV, we have to convert it back to RGB because that's what we've been using for the rest of this program. That's okay though, because Python actually has some inbuilt tools to do that conversion for us. So let's go ahead and try that. So now instead of randomizing R, G, and B, I am going to randomize H, S, and V. Actually, I think in this color system, we are, yeah, all the inputs and outputs are in the range 0 to 1. So this is different to what we're using here, where it's between 0 and 255. We're going to have to convert that as well. But for now, let's just do this. Random already returns a value between 0 and 1, so this will be good for us here. And as I mentioned, for S and V, we're going to keep it max, 100%. Okay, so we have to now convert HSV to RGB, but also to 255. So there's a tool for that, I believe, here. HSV RGB. Give that a go. But this is going to be a float output as well. Okay, so all we have to do is just multiply each element by 255 and also cast it to an integer. So we should be able to do that pretty easily using list comprehension. X for X in float RGB. Want to do multiply by 255 and also convert it to an integer. We can just return that. Well, actually, this might complain because we're returning a list, but it actually wants a tuple. So I'm just going to cast it to tuple as well. All right. So now if I run this, my goal is to just have vivid and bright colors being generated here. Yep, seems to do the job. Everything I have is very bright. There's no more sort of, this one looks a little bit desaturated. Let's see. Well, for the most part it works. I'm not sure when it's like really bright if it's just overlaid on top of each other so much that it sort of becomes white. So that could be happening as well. But the colors themselves seem to be a lot brighter than we had it before. And if we look at through all our samples, that appears to be the case as well. Okay, that's pretty cool. So now the last thing I want to do, you may have noticed these images are really pixelated for their size. This is 128 pixels, and I think that by drawing these lines, it just draws, just like pixel-wise really sharp. There's no smoothing or blurring or anything. So I want to fix that because this just looks a bit too lo-fi for me. I looked online on how to do this with Pillow, and it seems like the only way to do this like quite easily is literally just to downsample it in half. So reduce the size by half and choose an anti-aliasing smoothing method. But the problem with that is that now we're going to have an image that's twice as small, and I still want it to be quite big. So what I'm going to do is I'm going to pick the actual size that I want and then create a scale factor which multiplies everything by that scale factor, so that I will create an image that's bigger on purpose just so I can resize it down. So let's give that a shot. So let's say I want it at 128 pixels as a final result, but I have to multiply everything by 2. All right, let's give that a go. This applies to my padding as well, and also the line thickness, because that's guess we could just do this. Okay, so now I should make the image twice as big, but I haven't resized it yet. Let's just see if that works first. Yeah, well, it seems to work. Twice as big now. Okay, so we'll just do this exactly right before we save it, because we don't have to do it before. Image, resize. Well, we already have this number, don't we? Target size. Okay, that's a tuple, isn't it? Okay, and then for the sample, that's how we anti-alias it. So there's a keyword there. Okay, image.anti-alias. Right, there we go. Let me run that again and see what happens. Oops, got an unexpected keyword. Okay, maybe that's not the one. Resample. Okay, so let's run this again. Still really not that smooth. And again, that's because this image resize doesn't actually resize it in place. It creates a new image. Yeah, it returns a new image, resizing the original one. So if we want to save the resized image, we again have to assign it back into this variable. Let's try that. Okay, now I think that's smooth. It's also pretty blurry. Let's increase the size of our output a little bit. Instead of 128, let's make it 256. Okay, I think that looks a lot better. Yep. And yeah, that's pretty much it. You can probably extend this to do a bunch of other cool stuff. So it's just a starting point, just a simple way to get started with some generative art in Python. Or if you're new to image manipulation as well, this is, yeah, probably just a good way to get your feet wet. We've reached the end of the tutorial. I hope you found it helpful, and I hope that by this point you now know how to create images like these using Python. If there are any other topics or tutorial projects you'd like me to cover, please send me a message or let me know in the comments. The source code for this tutorial and the original NFT art collection project I mentioned earlier are in the description below. Thank you for watching.